Algebra 2, Unit 1, Day 3, Inverse Functions and Relations Homework Tutorial. Again, I'll work through some selected problems with you all, and I hope you understand. From 1 through 4, they want us to find the inverse of each relation if possible, and then state the domain and range. Remember, a function has to be it has to be a function first, so no x's repeating. When I look at 1, no x's repeat, so that's good. It's a function. Then it has to be 1 to 1, meaning no y's repeat. When I look at it, -3 is a repeating y, so an inverse is not possible for number 1. Again, it has to be a function, no x is repeating, and it has to be 1 to 1, no y is repeating. On number 3, I don't have x's repeating, so it is a function, but I do have -3 repeating as a y value again, so it is not possible to write an inverse. Number 5 wants us to find the inverse of each function, if possible, then graph the function and its inverse. Label 2 points per function. So let's graph y equals 4, because we probably forgot what that kind of graph looks like. So this calculator is similar to the calculator we have in class, except for the calculator in class has color, which is nicer for your graphs. So keep that in mind. So I'm going to graph y equals 4. So that's a horizontal line. Let's bring up the table. So if you look at it, all the y values are 4 for this graph. So it's a horizontal line, and I have repeating y values, right? So is it possible to write an inverse if you have repeating y values? No, it is not. So not possible. Now let's look at our next function on number 7. Y equals 2/3 x plus 2. Again, we probably forgot what that looks like, so let's graph it. Alpha y equals trying to get my fraction up there. It's not allowing me. I'll have to play with that feature a little more. So in this part, if that's possible, that you can't use alpha y equals to do your fraction, then you're going to have to use parentheses. So parentheses, 2 divided by 3, close parentheses, and then hit x plus 2. But I'm hoping on your fancier ones it's possible. So let's graph it. Look at the graph. Does it pass the horizontal line test? Yes, it does. So it's 1 to 1, meaning the inverse is possible. So let's look at the table and use some good solid points to plot our graph. So I see a solid one at 0, 2. So right here. And 3, 4 is another solid one. If I were to go to the negatives, there's a negative 3, 0. That's another good point right there. And now that I have 3 solid points, draw a straight line with a ruler, folks, through these points. And it's okay that it extends beyond those 3 points because it is a line that is continuously moving. So add your arrows. Again, you're labeling the 3 points, or at least 2 of them. Label means write the ordered pair. So 0, 2, 3, 4 was those. And I probably shouldn't have put them there because I now have to graph the inverse. Well, remember, inverse simply means switch x and y, correct? So we know that on the inverse function, or if on the regular function, I messed up, sorry. That's negative 3, 0. All right, let me write all these above. I'm sorry. All right, 0, 2, and 3, 4. So we know from our definition of an inverse that if those 3 points are on the original function, then if we switch x and y, we'll have the inverse points. So that means 0, negative 3, which is here. We know 2, 0, which is here. And we know 4, 3, which is right here, are the inverse points that we can use to graph our line for our inverse. All right, so that's enough fun playing with the graph. But we still have to algebraically find the inverse. We found it by graphing, but now we need to write the equation of this inverse. So we must practice that skill. First things first, switch x and y. So x equals 2 over 3 y plus 2. And then solve for y, get y by itself. First, you plus 2 on both sides. I'm sorry, yeeks, 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 absolutely not. You subtract 2 on both sides. And by doing that, you would have x minus 2 is equal to 2 over 3y. And then, to get rid of the 2/3, you have to multiply by its reciprocal, which is 3 over 2 on both sides. When you multiply by the reciprocal, it cancels out the 2/3 on the right, so you have y equals. And then on the left, we have to distribute the 3 over 2 to x, so that would be 3 over 2x. And the 3 over 2 to a negative 2, is going to give me minus 3. If you don't trust me, use a calculator. So y equals 3 over 2x minus 3. Now we can come to the calculator and graph that line. Just double check. So go to y equals. On Y2, we're gonna change it since again we don't have color on this on the Android one. If you were to, you can download this Android emulator on your cell phones or your tablets and or a computer or laptop. It doesn't work on Mac, I don't believe, or on the iPhone. But again, it doesn't come in color. So if I want to change how the line appears, I would hit enter until I get a line that I like. So I'm gonna get a dotted line. There's a dotted line there. So I can tell them apart since again I don't have color. And now I'm gonna put 3 over 2. So I have to put it in parentheses since this is not cooperating with alpha y equals 1. And then x minus 3. Now hit graph again. Uh, you can't really see that it's dotted very well. So maybe let's go back to y equals 1 and change it to the thick line. Maybe that'll be better. Graph. There's graph 1, and there's the thicker line. Yeah. So another way to remember which one is which is whichever equation you put first is the first one that's going to graph. So there's my thicker line or my dotted line. And if I pull up the table, you see 0, negative 3, you see 2, 0, and if you scroll down, you should see 4, 3, just to confirm. So 4, 3 for Y2, yes. For the last section, they want us to verify if the functions are inverses and write yes or no. So we're going to have to use composites to verify. The first one we're going to do, and I'm on number 9, is fog. So that means my candy shell is the f function because it's first. So write out your f function, 2x plus 3. Next, we're going to open a blank parentheses in place of x. So now we're ready to insert our gum, which is the g function, into our candy shell. So that's 1 over 2 parentheses x minus 3 is your g function. But there's still a plus 3 attached. So now we would simplify it, starting in the, well, what I would do is distribute the 2. So 2 times a half is just 1. So that leaves me with just x, sorry, minus x minus 3, and then plus 3. And then we know minus 3 and plus 3 cancel each other out, so we're left with x. So fog checks out. Now we need to golf and see if it checks out. So this time our candy shell is the g function, so it's 1 over 2 times x minus 3. So now I see x inside the parentheses, so I'm going to turn this into a bracket and so that the parentheses don't get confusing. Now I'm ready to insert my gum function f into the g function. So I'm going to insert 2x plus 3 Bring down the minus 3 and the square bracket. So now we start in the brackets and work our way out like order of operations. So inside the bracket, I have 2x plus 3 minus 3. So the plus 3 and the minus 3 will cancel each other out. So I'm left with just 2x. And then I distribute 1/2 to 2, which is equal to 1. So x is just left. So this method also checks out. So since both composites are equal to x, we now can say with confidence that yes, f of x and g of x are inverses. Again, you must do both Fogg and Goff. They have to equal x and only x. And then when they both do, you say yes. If only one does, you must say no. This concludes your tutorial on this assignment. I hope it helps.